Hello everyone. Here we will see 8 queens problem by arranging 8 queens in the 8 by 8 chessboard without allowing to each without allowing the queens attacking each other. Criteria is to avoid the attacking each other, we should not place the queens in same row or same column or same diagonal position. Here we can place the ith number of queen in the ith row. So there is the possibility of solutions 64c8. So here we are having the this many number of solutions, but here we are having only 92 number of valid solutions. Out of this 92 solutions, only 12 number of solutions are basic solutions. The remaining 80 solutions can be generated using reflection and rotation. Now we will select the method number 2 by traversing all the rows in single column at a time of placing the queen in that position. Here we will select the leftmost column here, then we will place the queen. Once we are placing the queen, then we have to traverse into the left horizontal direction to check any queen is already placed in that row or not. That means here there is no position, but if we place the queen in this column in the row, then we have to check is there any queen is available in the previous columns of the same row. If it is there, that previous queen which is already placed here, it will attack the newly placing queen. So we have to identify that position as a safe position or not. If any queen is there here in the column, then we have to move into the other rows, because we are selecting single queen, and we are moving into the all possible number of rows. Likewise, we have to check the diagonal position. Suppose if you take this queen, we have to check in the horizontal direction of left side and also this diagonal position. So if it is there any queens, then we cannot place that queen in that position. If this right side we need not to check it, because there is impossible to find the queen on the other side of the board 8, because we didn't place any queens in this right side. If this process succeeds, then we can mark that position. That means if there is any queen not found in this previous columns, and here the diagonal position, then we can go ahead by marking this position as a safe position. Recursively we have to apply these steps for all the columns, so until placing all the queens. So finally we can uh, print the solution of this chessboard after placing all the 8 queens by placing the last column in the solution, because we are placing the queens column by column, so we are trying with all possible rows in the single column. Then we can apply the backtracking method to find another feasible solutions. For example, here the queen 1 is placed in the first column in the first row, so we have placed here because there is no state in the horizontal direction and diagonal direction. Then it is placed in the safe position. Then queen 2 is checked in the second column. The second column we cannot place in the uh, second first row because already it is there. Then we have to go for second row. Here it is the diagonal position, then we cannot place it here, so we have to go for next column. The next column we have placed the queen 2 in this position. So now partial solution is 1 comma 3. Then queen 3 is placed in the fifth column of the third row. So now the partial solution is 1 comma 3 comma 5. So like that, queen 4 is placed in the seventh column. So if you place it in this place, so it is attacked by queen 1. So here if you place the queen 4, here it is not attacked, so we can place in this position also. And here queen 4 you cannot place in this position, so there is the possibility of different position. Here queen 3 it is not placed, queen 4 attacked by the queen 3, this is also position attacked by this one. So here queen 4 is placed in this position. So like that all 8 queens are placed. Now the feasible solution is 1 comma 3 comma 5 comma 7 2 4 6 8. Then there is possibility of many solution in the backtracking method. So solution number 2, here you look at that queen 1 is placed here, queen 2 is placed in the fourth column of the second row, then queen 3 we can place in the second column of the third row. So here there is no queen in the diagonal position and no queen in the previous rows, so we can place it here. Like that queen 4 we can place in the fifth column of the fourth row. So there is no queen in the diagonal position, and here the left side also not available, in the same column is also not available. Then queen 5 also can be placed in the this position. So as per the diagonal position here on the left side and this one, so this position. So like that we can place the sixth queen in this sixth column of the sixth row. Now queen 7 we cannot place in the safe position. You look at that, if you place it here, here also we are having uh, q1, so it is attacking here, q3 is there, and here q5 is there, here q2 is there, here q4 is there, so here q6 is there. In this position the diagonal position q6 is there, so here in this diagonal position q4 is there, so we cannot place the q7 here. So what to do, we have to apply the backtracking. Each previous queens to have be adjusted by applying the backtracking method. Then as per backtracking method, now q1 is placed, changed this position. Previously it was in this first position, now it is changed. So now we have got the feasible solution, fourth position for the first queen, second queen sixth position, third queen 8, fourth queen is second position, fifth queen is 7, and 6 is first position, seventh queen is in the third position, and eighth queen is in the fifth position. So this is another one feasible solution. Now the time complexity for this one is, for checking the position for each queen is order of n, either it is possible or not, and inside that we are having the recursive call to call the backtracking. That is also order of n. This is one for loop and this is another for loop. So here we are having the inner nested for loop, so it is taking the order of n square, and to find the safe position inside the loop by using the recursive calls, we are having safe position for recursive call of all the previous solutions, that is the n into tn minus 1. So the recurrence relation is order of n square first step added with n into tn minus 1. So when we are solving this t of n minus 1, we have to find by substituting the n minus 1 here, n minus 1 whole square. So here n minus 1 whole square, minus 1 is the smaller term, so we are ignoring that minus 1 here, n minus 1 whole square, so here the minus 1 is the smaller term, so we are ignoring that. So finally order of n square, then we are substituting the n minus 1 in the place of n, here the n minus 1 minus 1. Okay, so we are getting the n minus 2, equation number 2. We are replace that equation number replacing this term t of n minus 1 in the equation 1. So when we are replacing that, we are getting the term order of n square plus uh, n, this n, then we are substituting the values of this term in this position. So order of n square plus here n minus 1, this n into n minus 1 into t of n minus 2. Now we have to find the t of n minus 2. T of n minus 2 is the this term. So like that, when you are keep on replacing the terms, t of n, we are substituting the t of n minus 2 in this position. So when you are substituting that, we will get this term. Like that, when you are substituting the values for n minus 3, n minus 4, n minus n, you are getting order of n square. Then this term 1 plus n into n minus 1 plus n into n minus 2 plus n into n minus 1 into n minus 2 until t of 0. Here t of 0 will become 1. Okay, so now when we are substituting these values, so here it will become, this term will become order of n minus 2 factorial. Then this term will become order of n factorial. Okay, so here the order of n factorial is the maximum value when comparing these things. So finally the time complexity is order of n factorial for the n queens problem. Thanks for watching.